So my screen is visible to all of you, right?
Yes, sir.
Okay, so what we can do today's session? Last time only in yesterday session we have seen the Dijkstra algorithm also bit. We discussed the Prim and Kruskal and longest path discussed. Only the Bellman-Ford and Floyd-Russell algorithms remain. And Floyd-Russell will try to skip that, and only the Bellman-Ford will. Floyd-Russell already is it is and there is one tutorial, and that is will take much time. So that's why all of you can see there. That is a good thing, and very within more than 1.5 hours, I've discussed that Floyd-Russell algorithm. So very slowly with example. So all of you please see that it will be easy. Okay. And next thing is either we can go with this slide. Okay. So hope what you will prefer, all of you. I don't know. Or if it is a doubt, then we can go with the doubt only, because the slide is already there in the available in the portal. Anyone? No idea? Okay. So let's go with this slide. Dijkstra algorithm. So what is the Dijkstra algorithm? This is to find the single source shortest path. Find the shortest path from a fixed source vertex to every other vertex. Okay. And the fact is it is applicable for weight graph with positive weight edge only. It is not applicable for negative weight, as we have seen yesterday. Algorithm is to start with the source vertex I, initialize the distance value of the vertex I to 0, and other vertex should be, if you remember that how the sir is doing that in that graph, he started with the 0 I. If the Dijkstra algorithm is started from vertex I, then it is time is given as 0, and rest all time will think as an infinite thing, because it is not even fixed that at which time it is going to be born the other vertices. So this is the way, and update the distance value of neighboring vertices of the vertex. So as fire will move to other vertex, update with the weight, and each time new vertex is visited, update with the minimum distance value of it. Suppose some with the one vertex is burning time is 4, and some other path going to be the burning time is 2, then please update, means we have to update that vertex with the minimum distance. So that is the Dijkstra algorithm. Hope we have a study seen also. Based on that, we have one problem: an undirected weighted graph is given, shown in this graph. It is shown here, and the weight is also given. Okay, then the problem is, it is here: find the all positive integer value of x such that if we use the Dijkstra algorithm, the length of the shortest path from the vertex A to the vertex J. So where is the vertex J? Here is this is the vertex J, and here is the vertex A. So what are the possible value of x could be, so that the minimum distance will be less than 13. So we want to find the value. So this is the set of some values of x. What would be the possible value of x, so that the minimum weight, less than, sorry,
C subdivision, sir.
sorry, what you are saying?
C subdivision is the answer, sir.
C would be why it is so?
A to B, we'll go with 2. Even though A to D is 1, but before from D it reaches B, A to B will from A it will go to B.
Yes, the
And
updated one. Yes.
And then since we have to use X, so let's take X later. From E to H, only we have to go via H to J. So E to H, the shortest path is from E to G and G to H.
E to G and G to H.
H.
Yes.
So
Yes.
1 plus 2, and then H to J is 1, so 4.
1.
And then A to B is 2, so 2 plus 4, 6. So
Yes.
total count should be, I mean, total weight should be 13. So
Yes.
X can have 1 to 7.
Yes. Yes. And why it is no. So why it is how much it is 2 and then 1, this 2
A
and
to
then
B
1,
and
3
3,
and then 5 and this one 6.
6. Yes, sir. 6.
So
6 plus
6 are
X.
there. And what is the possible value of X is here. And if we suppose if it is 6, then we want 13. Okay.
Yes. Then X has to be 13 minus
Yeah,
6.
13 minus, so yes, 13 minus 6, so possibilities are 7. But if it is by this route, this B to C and then C to E, why it is not going?
That will also, if it is less than 7, then B subdivision should be correct. But if it is equal to 7 also, uh, then both ways it will go, sir, actually.
Yes.
Both ways the fire will go.
Yes. So for the lesser than that, it could be 6 till 6 it will go, but for the 7 it can go with B, C and then E or direct.
Yes, sir. So if it is, okay, they have given less than 13. So I think then
This
B
is
only.
less than 13, then it will be of which root? It will
B.
be
B
only B,
subdivision.
right? Because it
Yes,
is
sir.
not less than or equal to sign with, it is saying to be less than
Less
13
than,
only.
yes, sir. It is less than 13. B is, sorry.
Okay. So as here the same thing, remove the
Hello, sir.
H. Yes.
Sir, where we find this PDF in dashboard?
This PDF.
Yes, sir.
So this PDF I will update in for that live session summary, then you all of you will get.
Okay, sir.
Today I will give to update.
Okay, sir. Thank you, sir.
Yes. Okay, let's move to the next thing. So solution we have almost discussed that whatever is written here. And the stepwise, it is saying a way that remove the edge B from the graph and then find the shortest path. So it's just saying to be if you remove this graph and then find the shortest path. So the shortest path by removing this graph, sorry, this edge, then A to B, then C to E, then this G, then H, then I. This is only to be the shortest path. No. Is that this way or directly C to H and then J?
C to H, how can it be, sir? Because it will be C to H is
8,
8.
9.
8. Yes, sir.
It is 9. And here it is
Oh.
3, 1, 4, and then okay. So this is 7, sorry, 6. Yeah, so the updated H will be 6 here. Wait, if you write here H with the Dijkstra algorithm as says, the weight of the which vertex near to right, if you write the timing or even which is 6, but by CH it is going, then it is 8. So minimum value will be 6 here. Okay, so by removing this way, so as here it is says to be remove, then apply the Dijkstra algorithm. As here A to B, then this, and see what is the Dijkstra? Is exactly initiate the time, initial vertex will be 0 and the rest all will be given as an infinite time, and then remove that B, E and think the shortest path to go J. And once we think that the update will be here now, by this route if we'll go, then it will be 6, but directly it will be go then 2. So update for the vertex B will be 2, then here, then here. So it will be slowly, it will everything will write. Next step is going to be 6 here. And then fire will be moved in both side for H directly or by this way. So here it will be 9 as here this one. The next is G, then H, then J. So length is going to be, this is a bigger slide. Now the length of the path B to E is 7. B to E, the length of path is 7. Now edges B is as add to be weight for this edge should be less than 7. So W bet B is less than BC plus WEC, which is less than X is going to be less than 7. And okay, so let's move to the next. This is just whatever we have discussed. This is in the same. This problem. A company has branches in each of the 5 cities, C0 to C4. The fare in the amount 1000 is given for a direct flight from C1 to CJ is given by the ith j entry of the following matrix. Infinity indicates that there is no direct flight. Okay. Then the question is, an employee of the company want to travel from city C0 to city C3. So C0 is here and then city C3 is here. Okay. If she travel by the cheapest route possible, then the total fare she paid for the flight journey was how much she will pay. So all of you try to this problem. Try to solve this.
Is it 6,000, sir?
6,000. How you are solving this?
From C0 to C1, it is 2. From C1 to C2, it is 3. From C3 to from C0 to C1, it is 2. From C1 to C2, it is 3. From C2 to C3, it is 1, sir. So totally 6,000.
6,000. So do we need to draw the graph or without
Yes.
doing the graph?
With the graph only, it is easy, sir.
Yes. Okay, so anyone is here with solving? Also got different answer. So draw the graph of G. Represent the given adjacency matrix. So this one by this way, this is the graph. C0 to C1. C0 to C1 weight is 2. The fare is it is given, the fare of the flight. So the graph will be this one. C0 to C1. C0 to C1 means edges will be C1 and then C4. So C0 is connected with C1 and C4. This one. My this cursor is visible, right? This arrow, this pointer, right?
Where, sir? Yes, sir, it's visible.
Okay. And C1 is connected with C0, which is already, and then C2 also. C1 is connected with the C2. Here is C2, and then connected with C3. And C4 is for infinity, so it is not, there is no edge with the C1 and C4. And whatever its information is given, the graph will be exactly this one. Now again we will apply the Dijkstra algorithm. From C0 to reach other vertices, we need to do update. So from C0 to C1, here will be 2, and from C0 to C4 it will be 4. And then we'll move ahead. From C1 to C2 we'll take 5, and from C0 to C4 will take 9. So here it will be 5. And from C0 to C3 it will take 14, but here from C1 to C3 it will take 11. So update will be here 11. And then, and also this is 11, but still from C0 to C1, then C2, and then C3, then it will be 6. The minimum, then we will take the minimum one. Then it will be what? 6 here. And from 6 to, if we move ahead C4, then it will be 16, but here from C0 to C1 it is already given. So that's why it will be 4. So each weight is, we can write easily. So here I think in the graph here it is already written. This is the starting of the Dijkstra algorithm. So we'll do here 2. So see that this is 2 here, and then here is the next. Here it is going to be, here this side is 2, this side is, sorry, this side is 2, this side is 4. And see that here this is going to be 5, and this is going to be 4. The next step we can move ahead, this is going to be 6. So all other vertices is actually with the written with the minimum weight. Now it is says to from C0 to C3 will reach how much, and 6,000 will take to reach the cheapest price will be 6,000. Let's do this problem with the same this information, I think. But if an inspection team member wanted to inspect all the branches of the company started from C0 and ending at C3, visiting each branch exactly once, then which route should be the chosen to be in order to pay the minimum fare for the flight journey? So starting is C0 and ending at C3. So which route will be give the minimum fare for flight journey? But there is one condition that each branch should be visited once at least, not even exactly once. So even if he is reaching to C3, he have to visit all other vertices. All of you are trying or not, I don't know. With the same graph, it will work.
It could be 11.
It could be 11. How you are doing this? Let me show the graph. How you are doing from here? Anyone? So the final thing is C3, but he have to visit all vertices or all cities once, exactly once. So we started journey from C0. Suppose it is started C0 to C1, then C1 to C2. Okay, then C2 to which vertex he will go? Either he could go C3 directly and then C4 and then back, or he can go C2 to C4, then from C4 to C3.
But the minimum cost will not be in that direction.
So it will not be in that direction. So what direction would be good then?
So from C0, we have to go to C4, C2, C1, and C1. Sorry,
So from C0 to C4,
C4, C2,
then C2, then
C1,
C1,
and C3.
then back to here C3. So 4, then 5, 9, then 9, 3, 12, and then back here is 18.
Even that
This
is a
is,
big number. Yes.
sorry?
Even that is that also like looks like a big number.
Yeah, so if we go with like this C0 to C1, then C2, then it is 5, and then 5, this is 10, and then from 10, 10 again 20. So even this is greater. So which route would be good then? From C0 to C4, then this C3, still this is longer, no? So which would be the good then now? This is good one.
I think C0 to C1, C1 to C2, C2 to C3, C3 to C4.
And then
Direct.
directly, then anyhow, then again back, right? We have to back then. Because the destination is C3. Any other way? So minimum we got 18. Is that any other way to lesser than that?
We are not getting less than 18, sir. I'm not getting. 20 is the other number, but
Hmm. Yes. So let's see that. inspection team a member start from C0 and end at C3. In between, he has to travel C1, C2, and C4. Try to explore all possible paths starting from C0 to C3. So this is one way as here, and this is another way to here. So this one is keep 20 and another one is keep 21. So here is C0, then C1, then C0, then C1, then C2, then C4, and then C3. But we have different, no? C0 to C4, 4. I think there is a wrongness is here, I think.
No, sir. I think this answer is correct only, sir.
We calculated wrong.
Yes, sir.
Yes, sir.
So this is 4, then 5, 9, then 12,
Well,
and this is 21. No, 12, then this is 9, 21.
yes. Thank you.
And if it is this way, 2, 5, then 10, and then again it is 20.
90.
We calculated 18, so it is, yeah, this is wrong. So this is 21, and then, so this green part will be the path, minimum weight. So now the Bellman-Ford algorithm. This algorithm is used for finding the shortest path from a source vertex to every other vertex in the graph. In fact, this algorithm is applicable for both negative and positive. Okay, Bellman-Ford is applied for both. Dijkstra is only for positive weight age, but Bellman-Ford algorithm is for positive and negative, not applicable for the graph having negative weight cycle. Yesterday we have seen that what is the meaning of negative weight cycle. Algorithm is dj is the minimum distance known so for the vertex j. Initialize d0 from 0 means initial d0 is 0 if j is equal to 0, otherwise other vertex give the infinite. Repeat how many times? N minus 1 time. Why it is so? Because number of vertices is n. And how many times it should be go? N minus 1. If you do n time also, still there is a repeat of the, it will be a repeat. So we don't want repeat it. So number of n minus time will do. So for every vertex j and each edge jk belongs to E. Here is update is each time is there. dk is the minimum of dk and dj plus weight. So we'll see with this example, it will be easier to understand. For what value of x can we use the Bellman-Ford algorithm to find the shortest path for vertex path from the source is 0 to every other vertex in the graph. What is going to be the value of x? We want to find the value of x by using the Bellman-Ford, like Bellman-Ford algorithm will be used. So value of x would be, it is in the interval form, it is given. What will be the value of x? So from 0 it is started. So by 2 ways if you go, so weight of 2 is going to be 5 and weight of 1 is going to be 6. Now see that there is becoming a cycle, right? What is the cycle? 1 to 4 and 4 to 2 and then 2 to 3 again. Sorry, 2 to 1. There is a cycle is there. 1 to 4, 4 to 2 and 2 to 1. And Bellman-Ford says that there should be no negative cycle. So we have already 3 and 4, which is 7. 4 to 2, 4 is there, and 2 to 1 is 3. So we'll add, that is going to be 7. So what is the possible value of x will go, so that we are able to apply the Bellman-Ford algorithm? What will be the possible value?
1.
1?
Yes, sir.
No, we want to apply Bellman-Ford. So what are the possible value still we can give, so that Bellman-Ford algorithm could be applicable? Think in the case of negative weight cycle, we have it is in the graph, it have a cycle 1 4 and then 1 to 4 and 4 to 2 and 2 to 1, and see that the weight also, if you calculate the weight, which is 3 4 and plus x, 7 plus x. Okay, now what value of x will give, so that the cycle don't have negative weight? What are the possible value could have it have?
-7.
Suppose
-7.
if you will give -7, then what is going to be the weight?
0.
So any one of the interval contain -7? It contain, right, B and D. But it contain more than that also. Suppose the x value is 8, then -8, then what is going to be in that case? If x value is -8, then what is going to be the weight of that cycle?
-1.
So if it is -1, then can we use the Bellman-Ford?
No.
No.
Why? Because
Negative weight is not above.
negative weight
negative.
cycle we have, there is a cycle in the graph and with the negative weight.
Yes,
So
sir.
that's why we
Negatives.
cannot use Bellman-Ford. If it is x value is -8, even so can we give us some boundary to x value? So what would be the boundary if x value is greater than minus, so greater than means lesser than -7, then means lesser than -7 means 7 point -7.5, even 7.999, or even 7.9 or 7.1 -7.1. Still, what will happen with this? If it is -7.1, then
Weight of the cycle will be -0.1.
so again we have a cycle with the negative weight,
Weight.
right? So now here is it is giving a boundary. So what is the possible now interval? What is the possible value of x we can take now? Is there any idea all of you are getting? Which option going to be correct then in case?
C.
C, right? Why? Why do you think that C is going to be? So if it is -6, then in that case it have positive weight cycle, but even -6.5 also will work. So that means some boundary is not working for minus. It has some greater than -6. If it is -14 to infinite, option B is there. Then if you are taking -8 and it is available in that interval. So in that case we are getting -8. So that's why we have to skip that. If you think option C, then option C have boundary with the -7. That means what? The all values will be lesser than in the case of greater than -1 means -6 or 6.999, and each time if you weight the cycle of that weight of the cycle, then it will be always positive. It is not going to be negative. So that's why option C is going to be correct. Even -21 is also same case as for option B. Is this clear? Okay, let's move to the next. So consider the graph G. Now here we can discuss the Bellman-Ford algorithm also. Perform the Bellman-Ford algorithm. Suppose the source vertex is 0, we need to perform the Bellman-Ford algorithm up to 3 iteration. Okay. So we have to iterate Bellman-Ford algorithm 3 times. Up to 3 iteration we have to do this. So all of you try this Bellman-Ford algorithm. Okay, so let's do this one, Bellman-Ford algorithm. What is that? This is the box thing. dv started from 0 and we want to iterate 3 times, right? This one. So what is the algorithm? If you remember, if you have seen that Bellman-Ford algorithm, you have to give 0 when we are initializing from 0. So from 0 it will give 0 and rest all will be give infinite. Now we will do the iteration next. So see that in the next station. So we'll update the boxes which have connected with 0. So see that 1 is connected, 7 is connected. So we'll update with the 6. So to 6 reach to 7, we have directly 6 this one, or another route is there, 0 to 1, then 1 to this, and then this to reach here. So if we go with this way, 0 to 1, 10, and this is 11, and then from 11 to 7, if we'll go here, then it have -3 and 4. 0 to 4, 4 we can also reach directly 0 to 4. So what is the weight here? 4. So in the next step, we see that if we iterate with the next step, then there will be update. So I think there is an error here is happening here. Here should be what? Here should be we should here for 7. If it is going like this 0 to 1, then 1 to 2, and then 2 to 7, then there will be update. Here is some error is happening. Another will slowly update here, like vertex 2. If we want from 0 to vertex 2, how we can reach 11 with the 11? From 0 to we can reach 6 by 6 minus 2, 4. But if we go with this route 0 to 1 and then 1, this is going to be 11, 11 and then 7, this is 3, and then 3, it is 6, it is going to be 1. So there is an error. It should be not here 11. There should be an update. That each time there is a error is happening here. So I think in the last it will be updated. So third iteration is here 2. It will be not here 11. It will be 3. If we reach to 3, 3 is here. And by this way and then this way. So 0 to 1, 1 to 2, 2 to 7. Seven to 6, 6 to 3. So if you go with this, so this is 10, then this is 111, then here is going to be 3, then 3 to 6 is going to be 1, and then 1 to 3 is going to be 5, but here it is written 8. So it is not correct. Here should be corrected. What is happening here, or what is I am speaking, all of you are getting or not?
Sir, can you explain once again?
Okay. So there is a error in this. So let me take the screenshot of, and then we'll do. So we have this one, and what we can do from 0, we have to start. So dv is this, and from 0 we want to start. So this is 0, and then just a minute, in the proper notation it is okay. So from 0 it is started. We can assume V or even 0 is there. From 0 we are taking. Okay, from 0, and then other vertex are 1, 2, 3, 4, 5, 6, 7. Only 7 vertices we have. Okay. So in static, when we do Bellman-Ford algorithm from 0 in a slication, so starting, so this D0 is actually saying distance from 0. D0 means distance from 0. So from distance from 0 to 0 itself, what? It is initial time. So it is going to be 0 to 0 itself is 0. From 0 to itself, 0 is going to be 0. And rest all assume that it is infinite. a distance from 0 to rest all other vertices is going to be infinite. Infinite. It is not fixed. Now what we will do, we will update. What the update we will do in the next step, from 0, the connected vertex is 1, and this one, this one, this one, and this one. So let's update their distances from 0. Okay. So if we do update, so here from 0 to 1, from 0 to 1 is here. So from 0 to 1 is the distance is from 0 to 1 is 10, and from 0 to 7 is here. So it is directly age is given 6, but there is another route. If you go 0 to 1 and then 1 to here 2 and then here to here, count the weight now. 10, 1, 11, 11 minus 8, which is 3. And if you are going directly, then it is 6. So 7 is actually updated one. We'll write here, which is here 3. The minimum value will write. And now here from 0 to it is 4 is given here, which is directly it is given. So let's do this one. So this is 4 to, this is going to be what? 4 it is given. And rest all we don't know. It is still it is not updated now. Now in the next step, now let's update for the other vertices from 0. So from 0 to other vertex, let's say for 6. So for 6, if we go with this one and then 7, so minimum we have minimum one we have already written for 7, which is 3. And then 3 to 6 it is going to be 1. So from 0 to 1 it is going to be update with 1 now. And from 0 to and the next step from 0 to okay. So here it is 3. It will be, there is no other way to go. Here in starting it should be not 6. I just one step jumped here. That should be here 6. In starting I have, it should be 6. Slowly it will be updated. So slowly it will be updated. So here now from here to go 7 and then 2. So it is going to be 4. It will be slowly updated. In the next step, this is 6 and 5 will be reach. 5 is here. So in the next, and rest all will be here. It is going to be infinite. 4 will be 4, 3 infinite, infinite, and 1 will be written. Now in the next step, we'll do update. So from 0 to, so here is 0 to 1, there will be update 0 to 1 and then 1 to 2. The next step here is going to be 11. Now from 1, now here will be update, there will be measure update. So now here the 7 will become now 3. Okay, another thing, and other vertices 6 will be 3 and this will be updated 1, and 5 will be from 2 to we are now looking. So from 2 directly it will be what? 11, 1, and then this is minus 10. So this is going to be 1, 4. 4 is already 4, it is continuing. 3 is still we are unable to reach because from 2 we are looking. So this is going to be infinite, and 2 will be 11 as it is, 1 will be 10. So this is the third iteration. This is initial stage. This is next, and this is the first one. This is the second one. This is the third one. All here will be 0. So this is the first iteration, second iteration, third iteration. So this is going to be the updated. Slowly 7 times. How many vertices are 7? So 6 times we have to do iteration, and finally we'll get the distance from 0 to all other vertices by doing this. This is the Bellman-Ford algorithm. Okay, as here it is going. So yeah, this is 10, 4, and 6. Now it is correct. Then slowly update will be, now 4 will be updated here. Okay, so this is 10, 4, 11. In the next step, we can go to 6 now. So update will be here 4. No, this is correct. This is correct. One by one step it is actually reaching. So as now I have did. So see that now the other vertices all updated as here. I have also updated. This one 3 by this route. This is 8. So all other vertices will be updated. So this is the third iteration. Okay, let's do the next problem while using the Bellman-Ford algorithm for the graph. So what is all of you are getting what I'm doing here, Bellman-Ford algorithm?
Yes, sir.
Okay, now let's do this problem while using the Bellman-Ford algorithm for the graph shown below. D is the shortest path distance of the vertex V from the source vertex. 7 iteration. So vertex B from the source vertex after 7 iteration. What are the values of D3? Okay, so you have to find that D3, D4, and D5. It is asking distance of 3 from 0, distance of the vertex 4 from 0, and distance from the 5 from 0. And the source vertex from the source vertex after 7 iteration. So that means we have, in Bellman-Ford we have to complete all the steps. Till here we have already done this one, and now see the update here. Now see slowly the update is coming here. 1, 4, 4, 8, and 11. So in the next step this is going to be 10, 0, 11, 5. How 3 become 5? 3 is here. So if we go by this way, 0 to 1, 1 to 2, 2 to 7, 7 to 6, and 6 to now 3, then it will be very minimum, which is 10. So this is 11, 3, 1, and 4 will become 5. Okay, so this is the in the next step there is another iteration will go. So this is the last iteration. 0, 1, 2, 3, 4, 5, 6, 7. 7 vertices are there. So 7 iteration will be done here. So see that it is 6 iterations should be done, but the 7 iteration is actually saying that this is the saturated thing, like there is no need to do further iteration. So this is now the final thing. So distance of 3, vertex 3 from 0 it is 5. Distance of the vertex 4 from 0 it is 2 is here. So last column is actually showing you the distance from the 0. Okay. Then as here we can do, we did here till this one. So by reaching to here is 3, as actually by this route we'll go here this and this, and then this, then it will be 4 minus 2 4, and then 4 4 8 will be here. So but here it will be 8, and now but we are reaching to by this route, this and then this, so it will be now 5. Now in the next iteration, what will be the other vertices? So from 0 to 0 will be 0, from 0 to 1 it will be the same, from 1 to 2 it will be the same. 3 is already 5 now. It is, if it is lesser than that, no. So 3 is any other route to go reach 3, so no, there is no, so still it will be 5. And 4 is here, so 4 will go to, from 3 we have already reached here, so from 3 to 4 we can reach. So what is going to be update? So already we have 3 is 5 and this is minus 3, so there will be update of 2. This will be 2. Now 5 is there, so 5 is already, by which route to reach 5? Only the one way, which is here, this one. So there is no update will be there. And 6 is here, so from 2 it is already, so it is going to be already the same, so this is the 1, and 7 is already done, so this is 3. Now the next iteration, we have reaches to 5 till 4. So 0 to 0, 0 to 1, 10 will be, this will be the same. And now any other way to reach 3, so this is going to be the same, 1 2 3 4 5 6. I think it is always going to be the same now. 4 is 2 is here in the last design, but what we got, so 4 is 2 already we got, so 4 will be here, 4 4 4. After reaching 3 it will be here 4. The last iteration is here 6, what we did earlier. So our answer is matching, I think so, from this one, this 10 11 5 2, 10 11 5 2 1 1 and 3. This is 5 2, this is the last one, and then we can write the finally distance 3 is 5, distance 4 is 2, distance, the vertex of 5 is 1.
Yes, sir.
Okay. So now this is Floyd-Warshel algorithm. This will try to will skip this one. This is will take much time. We can skip this one. This is Floyd-Warshel is going will take more time. Once you watch that tutorial, then we'll do this. And after the Floyd-Warshel, minimum MCST, the minimum cost spanning tree. If we want, we can do one problem, but we have already spent much time. Okay, so Prim's is there. We already discussed this. So let's move on to the problem. So this is the problem. Consider a weighted graph G with 7 vertices is given here, which is represented by the following adjacency matrix. Okay. Now, if we perform Prim's algorithm to start with the vertex R, then the order in which the vertices will be added to set TV. So what is going to be here? So here it is given as here the set TV is this. Enter the letters in order separated by comma. So if you perform Prim's algorithm, start with the vertex R. First we have to find the, we have to find the graph, and then in which order we'll perform. If we perform Prim's algorithm, okay, with R vertex, then order in which the vertices will be added to the set TV is. So what is going to be the order? In which order we will do to find, we have to write the or that vertex order in which the Prim's algorithm is performed. So all of you please try this. So all of you are trying this. Am I audible right now?
Yes, sir.
So all of you are trying this problem. Okay, so I don't know. Let's first, without to do this problem, we have to draw the graph, because adjacency matrix is given, and easily we can, from the adjacency matrix, we can get the graph. So the graph will be this. This is the graph. Now just need to perform Prim's algorithm from the vertex R. So this is the vertex R. So from R, the vertex, the edge, the minimum weight is going to be 1 here. And then we'll start growing. So start growing with the vertex phi, because this have the minimum weight. So now this is R, U, and then V. And then from V, we'll start growing with the P. Here P, because there is no other vertex. And from P, we have two ways. So minimum weight is for the 6. This is 9. So this is Q now. And from Q, the minimum weight it have 8. So it will move to S and then S to T. So see that as here it is. So initialize TV with 5 and T is 5. Start vertex R and update TV is R. So TV is the collection of vertices and T is here it is saying to be it is empty. 5 means empty. And now from R it is started. Then from R the next is going to be U, as just now said, this minimum weight is U, and then V and RU, and T is going to be RU edge. This one, this edge. Now next is what? V. So TV is going to be RUV, the set of vertices it is, and T is the edges. So RU and then RV is there. The same it is growing as I just now said, they started growing, then it will be added T, then Q, then S, and then T. So if you see that this is the order, then U, then V, then P, then from P it is going to be Q, and then S, the next is S, the next, sorry, this S, then after T. So T, so this is the TV. So this is the order of the vertices, and edges will be in the same order we can write. Okay. Finally, TV is going to be the set of vertices, and here this one is the set of edges. Okay. So similarly, we can perform the Kruskal on this. The next problem is for the Kruskal, and we are going to skip this one. So I am just becoming as it is open. Please let me your doubt first. Okay. If anyone have doubt, please raise your hand. So that please let me know. We'll discuss now the doubts and then close the session. I don't know all of you are getting or I am just speaking.
I got it, sir.
Okay. So anyone have doubt?
Sir, I have a doubt from week 9.
Week 9. Okay, what is your doubt?
Sir, activity 9.3, question number 2.
9.3. Question number 2.
Yes, sir.
So what is your doubt here?
Sir, can you explain this question? I did not get it.
So consider the parallelogram as shown here, and theta is given 60 degree, and the perimeter of the parallelogram is 10 unit. Then which of the following is option is also height is asking h and the area of the parallelogram. So do you remember that what is the area of parallelogram?
Sir, 1/2 base into height.
1/2 base into height or only just base into height?
Base into it.
So 1 by 2 is for the for the triangle, but for the parallelogram is just base into height. So for this problem, so here as it is given 60 degree, right? So this theta is 60 degree and this is perpendicular. So this is right angle triangle, right? This is right angle triangle.
Yes, sir.
Okay, this is one thing. And so this is right angle triangle and this is a parallelogram, no? So whatever this one is there, this is going to be the same, right?
Yes, sir.
So whatever this one is 3 is here, this is also going to be 3. And these two are parallel. There is no use of the parallel thing, but yeah. This is whatever this length of the side is given, this is going to be same. Now this is a right angle triangle, right? So now we can use what formula to find this h? Sine trigonometric function we can use, right? So which trigonometric function will help to find this h? Sine or cos or tan?
Sir, I think tan.
Tan is, tan is for height upon base, right? What is the sine?
Sine is uh, perpendicular upon base. Perpendicular upon hypotenuse.
Perpendicular and hypotenuse. So sine will work here. Sine 60 is equal to h upon hypotenuse, which is 3. So sine 60 value is going to be what? Root 3 by 2. And this is h3. So finally, this is h. We can solve this equation and then this is going to be 3 root 3 by 2. Is this fine?
Yes, sir. But sir, how I know uh, sine will work cos like that?
So how we'll know? Because of, anyhow, see, this is the height is given. So we have to think that this is a right angle triangle. And in this week, we have already seen the trigonometric function, I think so. Yes. Right.
Yes.
Yeah. Earlier we have seen that also. So now we can use it here. That trigonometric angle is now. So this is the right angle triangle, and this is the 60 degrees given. This is the 90 degrees given. This is right angle triangle, so we can use then sine function. So how we will know that what is the place to use the trigonometric function is best whenever you are in the right angle triangle. Then easily whenever and some side is given, some angle. So the best thing is if it is suppose some angle is given. If some angle is given and then one side is given, then surely the trigonometric function will help. Otherwise, there is no ways to get that. So if angle and one side is given, then surely it is clear that you have to use the trigonometric function.
Okay, sir.
And then now finding the area is just base is what is going height is and what is the base here. So height it is we got, but what is going to be the base now? how we will find the base?
Sir,
Right.
sir, root hypotenuse square minus perpendicular square.
Uh, so here is how we can find this one. Then we can apply, the base into height. So what is going to be this one? How we can get this? Anyone? How we can get
Yes,
this?
sir. Yes, sir.
Yeah, how we can get this?
Sir, we have a parameter given question. N.
Yes. So now we will use the perimeter.
2L plus B is the formula of parameter.
Now
We
we will
have
use the perimeter. The perimeter is given as this whole, this is 10 meter it is given. The whole perimeter 10 is given. So if you assume this is L, then this is also L. So that means L plus 3, this L, then 3, and then again L, and then 3. It is exactly 10 it is given. So this is 2L is equal to 6, 10 minus 6, which is 4. So now it is L is equal to 2 we got. So base we also got now. So now formula base into height to find the area of parallelogram. So base is 2 and height is, we have already calculated here. So this will be cancelled out. 3 root 3 will come. Okay, this is fine, right?
Yes, sir.
Okay, anyone else have doubt? Okay, no one. So can we close the session now?
Sir,
Mhm.
sir, week 10 practice assignment solutions are not working.
Week 10.
Yes, sir.
Not in, it is 11 is not wrong. Okay, let me check it once.
Sir, 10 also, I
I have given to update the 11. Graded or practice, you are saying?
Sir, practice.
Okay, let me. Okay, it is. This one is also corrupted. It is showing a corrupted file, I think. And when I am downloading it, let me check once. Okay. Okay, I will give to update this one, the updated. So week 11 have the same issue. I have given the updated now, the updated PDF. It will now open. But now 10 is also have some issue. See, this will be open. This will open. So I will give to update. Okay. This
Okay.
10 also. Yes. I think 9 is also working. Only the 10 is remain now. Okay. I will give the two things like this slide also and then week 10 also. Okay.
Okay, sir. Sir, week 10 graded solution is released.
I think it is. I said to release the solution. I think it is released. Let me check once. Yes, it is released.
Okay, sir.
Okay,
Sir,
thank you so much.
sir,
Yes.
I had doubt in this question. I have pasted it. It's just from week, I think.
Okay, here, this one. Okay, let me open it.
Mhm.
In this problem.
Yeah.
Okay, launches new company with year 2010 with which make yearly profit in lakh as the polynomial is given. This profit polynomial is given for the first 12 year since the launch. When till there it is the profit polynomial is this one, where x is the number of years since 10. That is x is equal to 0 denotes the 10. Okay. In so for 2 year it have profit. Okay, and so on. Oh, sorry, for first 12 years. Okay, so let the loss be represented by minus sign of profit. Which of the following options are correct? So including the year in which the company was launched, it neither made profit nor loss. 6 time in 12 year, the company made profit in this year. The company made loss in these years. 2020, the 22, which is executorial, the company made loss. So it is easy to check, right? If you give just value here, and if it is negative or positive, based on that you can choose the option, right? It is just saying which is positive or which is company have profit or loss. That's
Yeah, I should thought that later on later. But if you
fine.
put the value of phi in every x value, at the
Mhm.
end we will be getting the negative.
Mhm.
So
The
I
company
want to
made
go there.
profit in year
For the last
5,
value
6.
Sir,
x minus 9.
sir, I
Yes,
think
sir.
we can solve this question by graph.
We can solve this by the graph, but
But there
even
was easy way, na?
yeah, there is an easy way, just substituting. The company made profit in year x is equal to 5, 6, 7, 8. So if you substitute here, because this one is given as profit. Oh, so this is yearly profit is given. Okay, that's fine. And
I also thought like same way, like just putting the phi in every x value. But for the first three, it will be getting right. But for the last one, it will be minus 4. So it will be not profit. For any value, it will
this
not be
5, 5,
profit.
5, and this no, still for 5 it is profit, no?
5 minus 9.
This is minus, but here is minus ahead.
So, okay, okay, right.
Still it
Okay,
is a
got it,
profit.
sir. Profit. Still, for 5, 6, 7, 8, 9, it's a profit, okay. And
Yes.
for including the year in which the company was launched, it's neither made profit nor loss in 6 times in the 12 years. So, 6
Yeah,
times
it is
neither made
neither
profit
profit
nor
nor
loss.
loss means how many roots are there? That's the meaning here. So one is the root, 2, 3. So how many roots are there?
1, 2,
0,
4, 5,
1,
6.
2, 3, 6. 6 roots are there. Right? 0, 1, 2, 3,
So
4,
6
5,
times 6
9.
neither made okay.
Profit
We
nor
should have
loss.
to consider okay. 6
Because
times.
the value at the roots will be 0.
Okay, right. Oh, okay, right. Yeah, getting it. In the 2000, in 2012, it made the loss. Like,
So at 1 it will be check. You can check the sign at 1. So at 1 it will be 0. At 10 it will be what? At 10 it will be positive. sorry, negative. So it will be a loss. But at 11,
It may be also
it will
loss
be
because
loss.
greater
But at 1, it's neither profit nor loss. So that's why it is going to be.
it's option D.
And option D, it is x is equal to 12, which is a profit. Sorry, x is equal to 12. So 12, if you substitute, then all are positive. Ahead one makes negative, then it is going to be loss. Correct?
Right. Minus 12. It will be minus.
Yes.
Okay, got it.
Okay.
Okay, sir. Thank you.
Yeah. Okay. Thank you so much for joining. Okay. So anyone else have doubt?
Sir, I have a doubt in activity 9.5, first question.
9.5. Yes, what is your doubt here?
Sir, how I find integral for this?
Okay, so 9 to 4 fx. So it is already given, no? Antiderivative fx. The capital F is the antiderivative of small f. So that means it could be written as right like this. This integration 4 to 9 fx, sorry, small fx, small fs, this x dx is, so antiderivative of this one is capital F, this x, and then this is 4 and 9. Now this is going to be f9 minus f4, and value is already given, right? This is 6 and this is 3. So this is going to be 6 minus 3, which is 3. Is this fine?
Yes, sir.
This is the what is the way to find the integration? You have to generally find the antiderivative. So antiderivative in the information it is already given. The antiderivative is capital F. Now we will substitute the limit here, and then the limit it is going to be this, and 3 it is going to be. Okay.
Yes, sir. Sir, I have one more doubt. So in activity 9.6, ninth question.
In this problem,
Yes, sir.
what is the doubt here?
Sir, in this we are finding integral of this. First, can you explain this graph?
This graph is, one is quadratic, both showing the quadratic. One is opening upward and another one is opening downward. So can you tell me which one is going to be for opening upward? And which one will be for downward? So there is no mean even. So this 3x square is actually opening upward. This 4 minus x square is going to be, if you remember the quadratic one, if if you remember that quadratic, if ax square plus bx plus c is there, if a is positive, then opening upward. If a is negative, then opening downward, right?
Yes, sir.
So f1 is 3x square and f2 is actually 4 minus x square. So that means this one, this, and then this. So this will represent this, right? And this will represent this, correct?
Yes, sir.
Now, if you want to find the area under this curve, so what is the way to find that? Which one will be function subtracted? f1x minus f2x, and then integration. And you have to find the intersection point of these two. So what is going to be intersection point? You just need to solve this equation, right? So this is what? 4x square is equal to 4. This implies x is equal to plus minus 1. So that means this is minus 1 to 1 will run. And now find the integration.
Okay, sir.
Sir,
Yes.
I have another doubt. I have a question.
Okay. 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 Yeah.
It's on graph theory only.
Okay. Dijkstra algorithm can be used to find the minimum weight graph.
So, because it cannot find for the negative weight cycle, so it cannot be used, na? The reason
No,
is
even not negative here. It is used for the minimum weight spanning tree or shortest
no,
path.
sir. It's for it's just for finding the path. I think it's not for shortest also. No?
Yeah, this is not for not even the shortest, sorry, not path, shortest path. With
Nice.
only the criteria is the weight of the wedges should not negative, but it is used for the shortest path. Correct?
And Bellman-Ford algorithm can be used to indicate whether graph has negative weight cycles or not.
Yes. Bellman-Ford is also for shortest path, but it allows the negative
Weight cycle.
weight, not weight cycle. Negative weights also allowed, but it should not contain
Okay.
any negative weight cycle.
So, negative weight cycle or not. So it can be used for Bellman-Ford can be used for negative weight cycles, right?
So here this optional Bellman-Ford algorithm can be used to indicate whether a graph has so Bellman-Ford is
Negative weight
used,
cycle.
right? Also by using while doing the Bellman-Ford, no? If you remember that Bellman-Ford, if you do the Bellman-Ford, no. So if you have negative weight cycle, no, so it will never converge to a final answer. It will always be decrease. So Bellman-Ford algorithm also will use to find that is there any graph have negative weight cycle. This is true. If you see the Bellman-Ford algorithm, so just now we were discussing, right? So Bellman-Ford algorithm is to find the from one single source vertex to all other vertex distances. So if it have n vertices, then you just need to find the n minus 1 time iteration you have to do. Suppose it have 5 vertices, so 5 times just 4 times just do the iteration. That is going to be the last column give your answer. That means distance from 0 or from
So,
whatever you are taking source vertex.
I got confused over there only. Like Bellman-Ford is for n minus 1. It will iterate for n minus 1 times, na?
Yes.
So
Yes.
if there was again a shortest part after n minus 1 times, it will not work now.
No, so it will not be lesser than, sorry. So in the next iteration, it will not. The reason is because if you have n vertices, then how many edges will have it have? It will have how many edges it will be have? N minus 1 edges, right?
Right.
So it means all the edges you have already completed. Now if you do the next iteration, there is no mean.
No changes. There will be no
No
changes,
changes
right?
will happen. Yes. But
Okay.
if
Okay.
if it have some negative weight cycle, then it will
Okay.
not actually it will be not the same. It will surely always decrease, 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 decrease. Always you will get different,
Right.
even more than that.
Right.
So it says that
Right.
yes, it have some negative weight cycle. That's why it is happening.
Okay. But it's not a perfect way. Now, float versal is the perfect way to find the negative weight cycle.
No, not even any algorithm is not apply for negative weight cycle. If it is if any graph have negative weight cycle, then no algorithm will work.
So
No
float versal will
algorithm
not
is
work.
applied. Even the fluid versal also will not able to do.
But
So
it can
any
reach till
algorithm will
the.
not work for the negative weight cycle. First thing, all of you please remember that if you have a negative weight cycle, the fluid versal algorithm
Okay.
will not work, or even any algorithm will not work.
So
Because how it could
float
be?
versal,
Huh?
like the float
The
versal.
simple reason is,
Yeah.
if you are moving by this way, okay, suppose this is a
Hmm.
cycle, no? This is a cycle in the graph. And if suppose this is 3, this is -5, and this is 1,
Hmm.
okay? And you are
Hmm.
going by this way, if you directly go, then the weight is 3. But if you go by this
Hmm.
way, and then,
Hmm.
okay, the next step is moving, in the head thing is, okay, here is, okay, here is not here, not this one, here. Okay, so if you go here and if you go directly here, then I don't know what will happen, or even okay, okay, or by this way, even not this one. Okay, the best thing is, suppose this is a graph, okay, and this is the graph, but there is one cycle is becoming here, which with the negative weight, let's say 1 minus 1. So if you are going by this way and directly you will give it, there is, it will weight in it, whatever the weight is there, it will be the same. But if you go by this way, then surely -1 weight will be decreased. And again if you do 1,
Hmm.
then it will decrease. Again do 1, -1, it will be decrease. So how is this
Right.
valid?
Right. Right.
It will never, it is not
Got
valid,
it.
right? Even this will
Right.
not
Right.
work for any algorithm.
Got it.
So for any algorithm, you have to avoid this cycle with the negative weight.
Okay. But what
But
it has mentioned, like it will fluorescence are used to indicate whether graph has indicate just to
yeah, so
indicate,
if
like.
the Bellman-Ford is is actually here catching, no? This is not converging, right? It is always decreasing, decreasing, decreasing. But
Right.
after n minus 1, it should converge, but still it is
So
continuing.
right.
That means it
Right. It
has
will
some
be
negative weight cycle. That's why it is happening. So that's why it is Bellman-Ford
okay.
is actually indicating, means here actually
Indicating
finding,
the
yeah,
value
it
will be
have the
changing.
graph have some error. It have some negative weight cycle.
Uh, got it. And so next option is
And in the next is Bellman-Ford algorithm is provide a solution for the single source shortest. Well, that's true, right? It is for the single source from one vertex to all other vertex. Floyd
right.
versal
Single
is for
source.
all other to all other, but Bellman is from one to all other.
Crude oil is for applicable for
All vertices to
uh,
all vertices.
the core also will not work for contain negative weight cycle.
Even Floyd versal is also will not contain any negative weight cycle.
Right. It will but it can indicate.
Floyd versal, no, may not,
No.
because there is no converging thing, no. If you see the algorithm, it is, there is no way to converging thing. But Belmont have this property that okay, there is no, there is, it says that only do till n minus 1 iteration. There is no need to go more than that. But it is not converging, or last one is not repeating, then it says it have negative weight cycle. But Floyd Russell don't have such thing. If you see that is finding SPG0, I don't know. That is a big algorithm. You have to find the length. Sorry, you have to find the path which have led to a path which have length 3. That is SP0, SP1, SP2, SP3.
Right.
So there is no converging thing, but Bellman-Ford have the converging property that n-1 time only have to do.
Like, sir, in Floyd Russell, like we will grow from that.
No, Floyd
SP
Russell is not
on.
growing. Floyd Russell is not finding MCST. Floyd Russell is for all vertex to all vertex shortest path, not the growing things there. You are or I think you are confusing. There are two ways. There are two methods to find, not only two, three methods to find the shortest path. One is Dijkstra, the second one is the Bellman-Ford, and third one is the Floyd Russell. There are three ways to find the shortest path. Okay, so I think you are confused with that. And next is the Prim's is the different. Prim's is different. Kruskal is different. Prim's and Kruskal to find the minimum cost spanning tree. But these three are actually used for the shortest path.
Right.
Okay.
Okay, sir. Thanks. You have cleared my doubt. Thank you. Sure.
Okay. Okay. Thank you so much. Good night to all of you.
Shubham sir, hello.
Yes.
Sir, have a little doubt in transitive closure.
Yeah, what is your doubt?
Can you explain transitive closure in short?
Okay. So, yesterday we have discussed the transitive closure is, again, it is a kind of relation. It is a kind of relation, if you have, suppose, simply, if you draw the graph, then it will agree. Otherwise, with the relation, transitive closure is a kind of relation property that suppose your grandfather is here, okay, and then your father or is here, and then the next is, I think, some
Like
thing
family
is
tree.
there. Sorry.
Like family tree, na?
Family tree. Then see, it is if it is this person is grandfather, and yeah, it is by telling this way is not correct. Let's do with the graph even. It will be more easier. So suppose the same yesterday graph I can take, or why it is a bit confusing. The simple thing is that if you have a path here, okay, I'm just okay. Suppose these are the vertices we have.
Yes.
Okay, let's do. I just remove this one, or no, I just added this one. So if you have a path, so suppose this is A, this is B, C, D, E, F. So transitive closure is a updated graph. Updated graph from this graph. Okay. From this graph, we will do some update. What update we will do, I will let you know. Okay. So we will do some update from this graph. So first thing, if you want to find the update, so means we have to find the same graph first. Okay. So this is A, B, C, D, E, F. So the same graph first, we have to write the same graph. Okay. Okay, same graph it is. Now, if there is a path, suppose I just took A from vertex A.
Yes.
If there is a path from other vertices, then I will. So here is we'll do update here, but let's do it. If there is a path from A to other vertex, then we will connect that. So vertex A is from vertex A to any other vertex, there is a path?
No.
No. So that means we'll not add that vertex A to other vertex. But
Okay.
let's do with this one will be more clear. If you take this vertex B now,
Okay.
so vertex B if you take, then there is a path to reach vertex D, right? Exactly the edge, this one, this edge.
Yes.
And also there is a path from vertex B to vertex C,
Okay.
this path. That means there is a path to reach vertex C. That means the path is available. So what we can do, if there is a path from other vertex, so I will add this.
Okay.
And now check for others. See, for others, F have the vertex here. Sorry, F is vertex here, and there is a path to reach vertex F from B. This and then this. So that means so what is the update I am doing? I need to add an edge connecting B and F.
So, Shubham sir, there is a path also F to C, so we can draw edge F to C
Yes,
like.
there is so one by one. That's why one by one, each vertex will check, and if it is there is a path to other vertex, we'll draw a graph. Sorry, we'll draw an edge
Okay.
between them.
Got it. Thank you.
So that is the called transitive closure. So this is the updated graph. From this graph, this is the update, and this is called the transitive closure of this graph.
Okay.
Okay.
And little doubt, while drawing Prim's and Dijkstra algorithm, the cycle should not be present. No.
Prims and Kruskal is even, Prims and Kruskal is not for the shortest path. So it could have negative weight cycle, it is allowing. Okay.
Okay.
This, but only the shortest path have issue that you don't have negative cycle because you are finding the distance. But
Okay.
Prims and Kruskal not for the distance, it is finding the spanning tree.
Okay.
Minimum cost spanning tree. This is not for the distance. So if it is the graph contain negative weight cycle, there is no mean of that in the case of Prims and Kruskal.
Okay. So in Dijkstra.
In Dijkstra have issue. Dijkstra is have issue. Even the Dijkstra is not allowing the negative weight. Bellman-Ford allows, but without negative weight. Floyd-Versal is also allowing the negative weight without negative cycle.
Okay.
Because why these are? Because these are finding the distance. And there is a issue with the cycle as here just now discussed. If it is the negative cycle is there, then always the distance will be reduced. So how you will say this is going to be the minimum distance?
Yes.
Shortest path. Because always it is reducing, no? So you
Yes.
cannot say. So that's why even Dijkstra, Bellman-Ford and Foyle will not use negative weight cycle.
Okay.
Okay.
Okay. Thank you.
Yeah. Okay. Thank you so much. Good night to all of you.
Good night.
Good night, sir.
Thank you, sir.
Okay, bye guys.